In the last video, we looked at very basic examples of if, else, and elif statements. However, things can get a little more complex than that, depending on your program's functionality. Let's have a closer look. To start this off, let's introduce something called Reynolds number. When studying the flow regime of some fluid inside of a pipe, if the Reynolds number is between 2000 and 10,000, this flow is transitional. If it's under 2000, the flow regime is laminar. If it's over 10,000, it's turbulence. We're going to focus on the transitional part of the regime. Back to Jupyter Notebooks. Declare a variable Reynolds number is equal to 5,000. To check whether or not this value corresponds to transitional flow, we're going to use multiple comparison operators. That is, if 2000 is smaller than the specified Reynolds number, whatever that may be, and if it's also smaller than 10,000, if Reynolds number is between 2000 and 10,000, we're going to print flow regime is transitional. And that is it for using multiple comparison operators. To check if a value is between two other values, and all of that done inside of a single if statement. You'll come across situations like this quite often. If we run the code, indeed this flow is transitional since it lies between 2000 and 10,000. Now if I change it to something that exceeds the range, for example 11,000, the if statement returns false. It does not lie between the specified range, and this code is therefore not invoked. This could have also been done with a logical operator. Instead, we could have written if Reynolds number is bigger than 2000 and Reynolds number is smaller than 10,000, print flow is transitional. In this case, the Reynolds number must be greater than 2000 and also smaller than 10,000 for this to return true. If one of these is false, if one of these evaluates to false, then the whole statement is false and this code is skipped. If we run the cell, clearly the code is skipped because this condition is not satisfied. 11,000 is not smaller than 10,000. Let's change this back to 5,000. I'm going to rerun this cell, and we're back in business. It satisfies both conditions of it being bigger than 2,000 and smaller than 10,000. Note how both if statements have the exact same results since they specify the same conditions, but just in different formats. Another operator that's often used is the OR operator. The OR operator, as we've seen previously, unlike the AND operator, only one of the conditions has to evaluate to true. So what we'll do, inside of a new cell, we'll write if Reynolds number is smaller or equal to 2000, or Reynolds number is bigger or equal to 10,000, then we can say print flow is not transitional. I'm going to change Reynolds number to 1000. Rerun everything, including the cell. Clearly the code is invoked because this condition is satisfied. It returns true, whereas this one is not. However, with the OR operator, only one of them needs to be true for the code to be invoked. This makes sense in our case because the Reynolds number is smaller than 2000, meaning that it's laminar and thus not transitional. If it's bigger than 10,000, it would be turbulent and also not transitional, as this condition would then be satisfied. So long as one of these conditions is true, with the OR operator, this code is going to be invoked. That sums it up for complex Boolean expressions. You learned all about if, else, and elif statements, as well as how to integrate logical and comparison operators into these statements. In the next video, we'll start talking about loops.